Dear students, in the previous video we discussed about context-free grammar and language. Now we are going to do push-down automata, which is a machine to implement context-free language. We'll have a small introduction about the need of PDA. We have regular language. I have given some small example for a regular language, that is ends with BBA, starting can be anything. And it has a limited memory. It's no need of any memory. For one state we need a memory. We do implement regular language in a machine that is called finite automata. Okay, that is DFA, NFA, epsilon, NFA, everything. And we have machine equation like Q sigma delta Q naught F. That is nothing but Q, number of states, sigma is alphabets, transition function delta, initial state and final state. Now, there are some languages they are not regular, and we are going to categorize not regular language as well as regular language as context-free language. Now, who is context-free language? It is a combination of regular language as well as not regular language. We do represent these languages, that is both regular and not regular, as in terms of grammar VTPS, that is variable, terminal, production rule and start symbol. We do required limited memory here, but for context-free language we need a good amount of memory because we need a power n, b power n, which is a counter. So it need finite memory. Now the question here is how we implemented regular language finite automata, how we are going to implement context-free language using push-down automata. Now through this push-down automata we can implement both regular as well as not regular, that's called context-free language. What is the machine equation for this? Q sigma gamma delta Q naught Z naught F. More detail we'll discuss now. The definition: push-down automata is a machine which accepts or rejects context-free language, that is both regular and not regular. It has a stack for a memory. Okay, it has infinite amount of memory device to store data. And we do have 7 components as a tuple. More detail we will discuss after some introduction. Now this is the basic diagram for your push-down automata. We do have a control unit called finite state machine. I told memory, so we have a stack is for memory. And using this particular control unit, you can either put some data or read some data. Call it as push some data and pop some data. And based on the input, the control system will work. Sometime it will accept or sometime it will reject. Pushdown automata is a machine which is combination of finite state machine, this particular unit, and memory device stack, this particular unit. Let us learn what is the stack before entering into PDA, because it is combination of FSM and stack. Now, what is a stack? Stack is an infinite memory usage having data access system in last in first out. That is, last term whatever you put here will go out first. First term whatever you go inside will become top of the stack and will go here. Now, data can be inserted in the stack using command called push. Now, I will just show push A. The moment I say push A, it will just go here. Now I am just pushing here, it will go and fall here. Again push Q, it will just go here. Again push B, it will go above that. Now answer, who is the last in B? Now if you take outside, the B will come outside as first. That is the reason we call it as a stack, last in first out. Now I would like to remove this particular B, that is bring out B first, then Q, then A, using the command pop. Now come on, remove this B. People will say pop B. Sorry, B is not required to mention, because if you use the word pop, automatically it will bring only this particular topmost data. Pop is enough. B will come outside. Again if you use pop, Q will come outside. Again if I use pop, A will come outside. Now the question here is it again can I use pop? Yes, use. What is there inside to come out? So the question here is how I know whether it is empty or still some data is inside. So to do that, some techniques we are going to use because we don't know whether it is empty or not. The technique is nothing but always the first element should be Z0, which is in the empty stack. You have to enter only the first term called Z0. The moment Z0 is coming, it is called the top of the stack. Data insertion in the stack with pointer. Always when it is empty, start with the term Z0, which will go as the top of the stack. Now in the stack, who is in the top is Z0. Then you push Q. Whatever the data you want to do, then you can start the work, but starting should be with Z0. Again you can do push. Now if you want to remove, if you use pop, B will come outside. If you use pop, Q will come outside. Now you will come to know who is in the top, Z0, which means that the data whatever we insert is completed. So that Z0 indicates last data. That is what the meaning. So in the definition itself, we used to mention what is Z0. Z0 is data in the top that indicates last data. Again, if you use pop, it will become empty. So let us do some examples. To learn what is the command and what is the transition equation, I will show some example. Now, this is the input string. This is the stack. Who is the first letter? A. Who is in the top? Z0. Now, we call it as a input. This we call it as a stack. Now, I am going to show some command operation. Try to learn theoretical statement. Then I will give the command. What is the work I am going to do? I am going to push A. Conditions applied. When I am going to push A, two condition. If input data is A and if the top of the stack value is Z0, if both are satisfying, if any one is not satisfying, don't do the work. If both are satisfying, what both are satisfying? If input is A and top of the stack is Z0, then you do push. That is, if input is A, accepted, top of the stack is Z0, accepted, then you can push A. What is the command? A Z0 / A. These two terms in the order input, top of the stack. Repeating, input, top of the stack. If these both are satisfying, push A. Here any letter I mentioned after / command is called push. If you don't mention anything, just if you put epsilon, then it is called pop. Because pop you don't need to mention the data. Now, this is input A. This is top of the stack Z0. Now, what I should do? Push A. I am going to do the work. What is the alternative command? Same. A is the input. Z0 is the top of the stack. Then you can push A. Now, I just pushed A. Is it accepted? Yes. PDA accept this particular work because input and top of the stack is matching the command. Let us do another example. Who is input? B. Who is top of the stack? A. Now let us read. If input is B and top of the stack is A, then pop A. Now you have to check whether it is working out or not. B, A. B, A. Don't say pop, it is nothing but epsilon. If input is B, accepted. If top of the stack is A, accepted. Then you do pop. I just popped. The A goes outside. PDA is working because input and top of the stack is matching. Let us see another example. If input is B and top of the stack is A, then you do pop. The command is B, A / epsilon. Why epsilon? Because pop. B, A. Command. Who is B? Input. Accepted. Who is A? Top of the stack. Hello. Top of the stack is Q now. Then it won't accept. PDA will reject. It won't work at all because top of the stack is not matching the command. Another example. Consider the language given and I am giving the command. Now you tell me. There is a input, there is a stack. A input, B top of the stack. If both are satisfying, do pop. Come on. Who is A? Input. Sir, not satisfying, sir. So PDA rejects because input is not matching. I will show you another example. A, A / Q. Input, top of the stack, push. Input, top of the stack, push. Who is input? A. So, not satisfying. Who is this A? Top of the stack. Satisfying. This is satisfying, but this is not satisfying. PDA rejects. Another example. Input, top of the stack. Come on. Who is this fellow? Input B. Satisfying. Who is this fellow? Top of the stack A. Satisfying. Wow, both are satisfying. Input B is satisfied. Top of the stack is satisfied. What I should do? Push Q. Above this A, I want to push Q. Yes, PDA accept. I pushed Q because both are satisfied. I have given a lot of example for this particular pushing the data and popping out the data. This is your DFA. And what is its transition equation? If the input state is Q0, if A is coming, it will go to Q1. Q0 for A input, it will go to Q1. What about in PDA? PDA is depends on input as well as stack. Now, the same Q0 state, the same Q1 state. Q0 state will become Q1 state with this work. If input is A and top of the stack is B, then push Q above the existing term B, then it will go to Q0. The transition, the result will be like this because you pushed Q above B. Now the result transition will be like this. That is, initial state is Q0, final state is Q1. Q0 will become Q1 when input is A, top of the stack is B, and you push Q over B. So you can sometime write Q comma B also, QB. Both are one and the same. You see, like this also you can write Q above B, both are same. I will show some more examples, something like this. Q0 to Q1 I converted. A comma B slash QB or Q. Whatever explanation I give, the same stories I have mentioned. Just I will show one more. Q0 become Q1. B is the input. Top of the stack is capital B, then pop. A is the input. Top of the stack is Z0, then push S over Z0. The explanation, everything I gave. In the state Q0, accepted. For the input B, and if the stack symbol is B, then pop, that indicated by epsilon. So pop B, that is called that B, whatever is there, it will get popped. And change the state to Q1. I am changing to Q1. Transition representation I mentioned here. Whatever the diagram I gave, I just mentioned as a transition representation. This is the initial state, this is the final state or next state. This is the input, that is what you are consuming now. This is stack content available here. You are going to do push Q over B. If I put epsilon, it is pop. Now let us go for PDA definition. PDA are the machine that accepts or rejects string of character represented by CFL. PDA are made up of 7 components represented as a tuple. And you know these 5 components are DFA, which you know already. Q, set of finite states, Q0, Q1, Q2. Sigma is input alphabets. Delta is nothing but transition function. Q0 is nothing but initial state. F is nothing but set of finite accepted final state. All these 5 were same in DFA. Now again it is repeating in PDA. But sir, you told 7. Extra 2 is this 2. Who is this particular 2? Gamma. Gamma is nothing but what are the symbols available in the stack. In the stack you had Z0, A, B, Q, whatever may be according to the problem. The set of symbols available in the stack. Come on. What is the reference? Sir, Z0 is the reference which is top of the stack. That is called the pointer. Z0 is the initial symbol on the stack pointer. So, this is the definition of the pushdown diagram I have mentioned here again so that you can understand this particular story easily. It is a finite state machine. It will take 2 things. One is about what is the input, other is about what is the content of the stack. If both are satisfying, it will do either push or pop and will accept and go to next state. If any one is not satisfying, it will reject. Is the just a detailed discussion about pushdown automata and its machine definition, 7 tuples I have explained. In the next video, I will discuss about problems on pushdown automata. With this, I would like to conclude this video. Thank you.